Hello and welcome to the video. In this video, we're going to interface PIC16F877A with ULN2003. So as you can see, I have created a new project named Stepper Moter in MPLabX IDE. First, make sure that you set as main project. As you can see, this is already a main project. Then create a main file in the source files main.c. Then let's begin the coding. I included the header library xc.h for compiler. Then I configured the bits, and then I defined the crystal frequency that is shown here. After that, we have three functions. The first function is step sequence. Now this sequence is as per our motor, that is stepper motor, with two coils A and B. The first step is to initiate the coil A plus and B plus. The second step is to initialize the coil A minus and B plus. The third step is to initialize the coil A minus and B minus. The last step is to initialize the coil A plus and B minus. After that, that is a delay function. The last function is stepper rotate. Now this function get two arguments. First is steps and other is delay. Now inside this function there is a for loop and another for loop that is nested. The first for loop is to initialize the steps, how many steps we have to perform. That I will describe in the video next. And the next for loop is for the sequences. Now as you can see, I start the variable j from 0. That will go up to less than 4. So in total that will have 4 steps from 0, 1, 2 and 3. Because we have 4 steps here. So we included j is less than 4, or you can do like is equal to 3. It's up to a person's choice. So for this video, let's go with this one. And after that one, we are writing this sequence to our port, that is port D, with a delay of this specified value. Now let's come to the main function. We started with initializing our port D as output, obviously because we are running a motor using ULN2003, so we will provide the output to the pins of ULN. The next is to clear the ports, to define the ports as on output. So initially they are in the low level. Next, in a while loop, we initialize our functions. The first function is stepper rotate. We give 100 steps to this function with a delay of 10 milliseconds, as you can see right here. And after running this function, we give a delay of 1 second. There is an overview of this code. Now let's go to the Proteus with a diagram. In this diagram, you can see this is PIC16F877A microcontroller. There is a basic circuit for crystal with 22 picofarad of capacitors in parallel. Now let's come to the port D. The port D, we are using the first 4 pins of port D from 0 to D3. And we are using the first 4 pins of ULN2003 pins. Now this is our stepper motor. Let me show you the configurations for this motor. We're using the 12 volt and step angle of 1.8. Maximum RPM, the revolution per minute, is 360. Coil resistance is 120. Coil inductance is 100 microhenry. Now, for this one, these are the coils that we are initializing. As per our sequence, we have connected these coils with our stepper motor. Now, we're going to compile this code and we'll copy the hex file to the Proteus. Let's wait part to the finish. As you can see, the compilation is done. Let's copy the hex path and move to the Proteus. Double click on the control path and paste it. We set the clock frequency to 20 megahertz and click OK. After that, let's run the project. As you can see, the motor is working now. These are the angles that are showing right here. So thanks for the watching video. I will provide the source link in the bottom of the descriptions. Check out and to subscribe my channel.